Okay, we have a lot to do in this video. Let's get started. Sketch the graph of each function, state the domain and range. So I've already listed that right there. Find the intervals of increasing and decreasing. Sketch the graph, so I have a table of values. So if you recall from Algebra 2, this form of a quadratic is already vertex form. Remember that from last year? So for the x value, whatever zeroes out inside the parentheses, so the additive inverse to positive 2 is negative 2. So here's our vertex. And then to find out the y value, you just, well, I'm sorry, that's silly because this is already vertex form. You take exactly what's on the outside. There we go. If it was standard form, then you'd substitute the x value. But this is vertex form. So we already know that at negative 2, we're up at positive 4. And notice there's not a negative sign in front of the parentheses. So we already know that this graph is going to be doing this. Now right there, that tells us a lot of information. We know that where x is equal to the x of the vertex, this will be the axis of symmetry. So that is where kind of have an invisible asymptote. That's the axis of symmetry, which means it cuts the parabola in half, all right? What that also does is it is the interval of increasing and decreasing. If we know the graph is doing this, if we look this way, that graph from somewhere up here to somewhere right here, that graph is decreasing. So for decreasing, you'd say from negative infinity till negative 2. And then look at where it's increasing. If you go from here to here, the graph is going up. So from negative 2. And what we're talking about, if we keep putting in numbers greater than negative 2, it's going to keep getting higher right there, right? If we keep putting in negative values, the number will get higher, but as you look left to right that entire way, as you read left to right, that graph is going to be going down. And then from here, so as you're looking at the x numbers, right, these x numbers, we're coming down on this side, so from negative infinity up till negative 2, and then from negative 2, as we keep going this way, the graph keeps going up. So that's intervals of increasing and decreasing. Okay, so we did that. So, and we still have our axis of symmetry. All right, now you're just going to pick two values to the left. So if this is negative 2, two values to the left, oops, is negative 3, negative 4. Two values to the right, negative 1 and 0. And remember what we learned last year about a parabola. Because it is symmetrical, if we put in a number here and get that height, that same distance away from, let's say, negative 2, will be at the same height. So if we put in negative 1, that's 1 away from negative 2. Well, 1 away from negative 2 is also negative 3. Those two should have the same height. And then 0 is 2 away from negative 2. And negative 4 is also 2 away. So they should have the same height. So I'm going to plug in 0 first. So if I put a 0 in there, 0 plus 2 is 2. 2 squared is 4. 4 plus 4 is 8. So at 0, we're up at 8. And negative 4, we're up at 8. Now I'm going to take the time and I'm going to put negative 1. Well, negative 1 plus 2 is 1. 1 squared is 1. 1 plus 4 is 5. So at negative 1, we're up at 5. And at negative 3, we're up at 5. Okay, so here's the interesting thing about domain and range for parabolas. For any polynomial, x to the positive integer, any polynomial, the domain will always be from negative infinity. This is what I mean. We can plug any real x number into this function and we will get a height. So that means if we can plug in any x number, negative infinity to positive infinity. But look at the lowest value at where it touches, and there's a solid dot right there. That's the lowest value, height value. So you would say the lowest value is 4, and it touches, so we use a square bracket, and it goes on to positive infinity. So let's recap. The decreasing, and these are the x values. So all of these x values, as you read up until -2, those y values are decreasing. So from the x values from negative infinity to 2, those y values will decrease. And then, let me do a different color. From -2, all the x values from -2 to positive infinity, those y values are increasing. All right, so this is the information that you will need to know how to do for the next exam. And sometimes you're not going to have this in vertex form. You could have y is equal, say, x squared plus 6x plus 8. Well, that's a quadratic that you could factor. Factors of 8 that add up to 6. But now we know the two x values. So watch what this does for us. I'm going to erase all this. Since we know that at -2 and -4, those two things will be symmetrical. So if we did our table, here's the vertex. Well, right in the middle of -2 and 4 is -3. So at -2, we're at a height of 0. And at -4, oops, I should put -4 because this is to the left, -2. Well, half of that is done for us. And then when we plug -3 into both of those, -3 plus 2 is -1. -3 plus 4 is +1. -1 times +1 is -1. So -3 would be here. Then all we have to do is put in -1. So if I put in -1. -1 plus 2 is +1. -1 plus 4 is +3. 1 times 3 is 3. And again, so for increasing and decreasing, notice the y values, all of these x values from -infinity up to -3, the y values, and we can actually, I guess, put a square bracket there because it's going to touch. I should have done that on the other one because it's actually going to touch there. And then look at on this side. So all of these x values from -3 to infinity, the y values are increasing. And then for domain, remember for domain, -infinity to positive infinity, always for a polynomial. And then the range, what's our lowest value? -1. And on this graph, it's going up, so you say positive infinity. All right, that is it for this video.